In this video, we're going to be reviewing how to solve equations. Now, you're probably asking yourself what an equation is, and all it is just a fancy way of saying that two things are equal to one another. And the most basic example of this is saying that 1 plus 1 equals 2. The left side of 1 plus 1 is equal to or the same thing as just the right side, in this case 2. Now, you're probably asking yourself, why do we bother learning how to solve equations? Now, I'll admit, as a student myself, when I was learning how to solve equations, I thought it was very tedious. I didn't think there was really a point to it. But really, what you can do when you know how to write equations and you know how to solve equations is you can use solving equations to find a specific value for a specific outcome. Now, I'm going to give you two examples, real-world examples, that you can use, and you can use solving equations to help solve these, just so you get a taste of what I'm talking about. So Eli buys a new phone and he puts down $160 when he purchases it. And he chooses in his plan to pay $20 each month. The whole phone is $700 and they want to know how long it's going to take until the phone's paid off. So I'm not going to solve this problem right now, but what this problem is asking is, when is Eli's payments, including the $160 he put down and the $20 each month, when is that going to be equal to the cost of the phone, which was $700? And in another example that we'll be visiting later, we have two t-shirt companies with very different price ranges as far as t-shirts are concerned, and you want to know, well, which shirt company are you going to order from? And something you're going to want to know is, when is one t-shirt company going to be cheaper than the other? And we're going to use solving equations to solve that as well. Now, we're going to get into the basics of solving equations. And the key to solving any equation or to find the value of any variable is to use opposite operations. That's going to be your best friend. So all that means is, if there is an addition part of my equation, I'm going to use subtraction to get rid of it, and so on and so forth. If I'm using subtraction, I use addition. Multiplication, I use division to get rid of it. And you'll see a couple examples of these in just a moment. Now here we have two very simple equations. I can see that this equation is telling me that 4 times a number is equal to 44. I want to figure out what x is, so I'm going to have to isolate this. And the way I do that is by using the opposite operation. So here I'm multiplying 4 times something, and in order to figure out what that is and get x by itself, because again, your goal at the end of the day is to get the solution of x equals something. So what we'll be doing is, instead of multiplying here, we're going to divide both sides by 4. Now, when we do that, this 4 is going to be canceled, and we'll just have a simple problem here of 44 divided by 4. Now, once I do this, I'm going to see that x is equal to 11. And I can even go back in my equation, if I remove the work for a second, and test it out to see, well, is 4 times 11 going to give me 44? And after a little bit of math, you'll see that that's true. So both sides are equal to one another. Now, in this example, we have a couple operations we have to deal with, because we see that there is some multiplication, there is some addition and subtraction, or I should just say addition, and the way we're going to get rid of this addition is by using subtraction. So I'm going to subtract both sides of my equation by 3, just like I previously divided both sides of my equation by 3. So adding a positive 3 with a negative 3 is going to cancel this out, and 57 minus 3 is just going to give me 54. So I'm going to have 9x equaling 54. And just like my previous equation, all I have to do in this last step is just divide. So I'm going to divide by 9 on both sides of my equation, and I'll see that x is equal to 6. And again, I can always test this out by saying, well, 9 times 6 is 54, plus 3 is 57, so both sides are equal. Now, in this example, it's a little bit longer and there are a few more operations. And again, your goal is to get your variables on one side and your constants on the other side of your equation. So at the end, you can use division to figure out your value for your variable. So what I'll be doing here is I want to get rid of the constants on the uh, right side of my equation. So in this case, what I'll be doing is I'll be subtracting both sides by 11, and you'll notice that here I have constants and variables, and sometimes what I tell students to do before I go into solving is I'll have them underline the variables in one color and underline the constants in another, so that way they keep track of what should affect the other thing. So I'm going to subtract by 11 on both sides. I'm going to have 4x not equaling, but plus 36. And that's going to be equal to 7x. And what I'll do now is I'm going to subtract this 4x over here because I want to get this side only full of constants so that this will cancel out. I'll also subtract 4x on this side. I'll have 36 equaling 3x, and from here I'm just going to divide both sides by 3. And here I'm going to get that 12 is equal to x. Now in this next example we have the distributive property. So what we'll be doing is actually distributing this 3, the outside number, to my other two values of x and 5. So in this case I'm going to have 3x plus 15 equaling 45. And from here I can subtract both sides by 15 in order to get x all by itself. I'll have 3x equaling 30. From there I'll divide both sides by 3 and I'll have x equaling 10. Now I want to talk about some common mistakes I see from students when solving equations, and the first has to do with the distributive property. And you'll have to be really careful while doing this because a ton of times with the distributive property, people will draw the arrows and they'll give me a result such as 6x plus 1 equals 32. And you'll notice here that while they did distribute the 2 to the 3x, they forgot to distribute the 2 to the second number within the parentheses, in this case the 1. If you do solve this correctly, what you should do is still you want to follow that first step of distributing to the 3x to get 6x. But then you're going to be adding 2 at the end because 2 times 1 is 2, and that's still equal to 32. And from here, I can still solve as I would normally. I would get 6x equal to 30. And from here, I can divide by 6, and I'll see that x is equal to 5. Another common mistake that I notice with students is they'll mix up their negative operations. Now, you'll see what I mean by this in just a quick second. So what this student is going to do is they're going to see that they're going to want to subtract the 12 to get rid of the constants on their left side. So they would subtract by 12 in this case, and this will cancel out. And they'll also subtract by 12 on this side, and while this won't cancel out, they'll end up getting 5x equals 2x, and somehow they'll end up with negative 12. Now you'll have to see over here what's actually going on in the green, because while if we do this correctly, you will still see that we get rid of the 12, but you have to remember that this 24 is negative. That minus in front of the 24 is telling us that we're actually adding a negative 24. Now when I do that, we're actually going to get a more negative value. So in this case, we'll actually have 5x equal to 2x minus 36. And from there, we'll still be subtracting by 2x to get rid of our variables on our right side. We'll have 3x equal to negative 36. And we'll still divide by 3 on both sides, and in this case we'll get x is equal to negative 12. Now another common misconception is using the wrong operation. So here you'll see what we're talking about. Now I see there's a couple negatives in here which might throw off a couple students, but the biggest thing I'll see is that they'll want to get rid of this 41. And if they choose to get rid of this 41 first, for some reason they subtract by 41 knowing well that here we're showing subtraction. So if they subtract by 41, they'll make the mistake of doing this, and they'll think that they're actually canceling out the 41, when in reality, if they subtracted by 41, they would actually get negative 82. Now, if you do this, you're eventually going to get an equation that is still solvable, but it is going to be very difficult to solve because, one, your solution is already incorrect, and two, odds are you're going to end up with a value with a decimal. So in this case, remember, you want to use opposite operations. So if I did want to get rid of this 41, or I should say this negative 41, I want to add by 41 on both sides. Now, this will still cancel out my negative 41 because these are opposites, so I don't have to worry about this 41 hanging around here anymore. And now, if I do solve this correctly, I'm going to be left over with negative 6x plus 45 equaling 9x. And then I'm going to want to also add my negative 6 to both sides. I'll have 45 equal to 15x, and here we can just divide by 15. And we'll get a solution of 3 equaling x. Now, I mentioned these two questions in the beginning of our video because I want to show you that you can use equations to actually solve real-world applications. It's not just a random thing we put you through for the sake of math. So if we remember how to write an equation, we can say that we can put this whole story into one quick equation. In this case, 20x plus 160 equals 700. Now, the reason we're doing this is Eli buys the phone at $160. That's the money he paid into the phone. And he's paying $20 per week, which is why this is shown as our rate of change. So I can actually figure out how many months it's going to take for Eli to pay off the phone. So as a normal equation, I would subtract by 160. I'm going to end up getting 540 is equal to 20x. And if I divide both sides by 20, I'm going to see that it's going to take Eli, in this case, 27 months to pay off his phone. So if you are somebody who's actually purchasing a phone and you know that new phones come out every year and a half, 27 months, that's about two and a quarter years. So you're going to want to probably, if you want to pay off that phone to buy your new one, put a little bit more into your payments each month besides that 120. Now, in our next example, we were talking about buying different t-shirts. And in this case, what we'll be doing is we're going to write two equations that are equal to one another, because what that's going to do is tell us when both of these t-shirt companies will charge the same price for the same number of t-shirts. So what I'll do is I'm going to write an equation for my left side, 15x, because that's our rate of change, it's $15 per shirt, plus 135 is equal to 20x, because that's the price of their t-shirts, plus the $15 shipping fee. Now, how I'm going to solve this is I'm going to subtract by 15 on both sides. I'll have 15x equaling, I'll have 15x plus 120 equaling 20x. And then from here, I'm going to subtract by 15x. I'm going to get 120 is equal to 5x. And then from there, if I divide both sides by 5, I'll see that we'll have to buy 60 t-shirts in order for the price to be the same. Now, just looking at both of these equations, and again, I'm going to mark up here that x was 60, it's obviously going to be way more expensive to buy t-shirts from this company, Super Shirts, initially, because buying a single shirt would cost us $150 versus buying a single shirt from Deluxe Tees would only cost us $35. But after that 60 shirt mark, where they're both the same price, Deluxe Tees has a larger price per shirt.